So in our last video, we are still in 1.7 and we were discussing how to find composite functions. And we were talking about the domain. So we had found the composite function that we were asked to find right here. And now I want to find the domain. So we have to follow the rules that we were given, which are right here. And we are going to look first at the domain of g of x. And the domain of g of x is this. And why do I know that? Because x is in the denominator. When I set the denominator equal to 0, there's no, I don't need to solve anything. It's already solved here. And this is the exclusion. Because remember, our first question said, if x is in the denominator, set the denominator equal to 0, and that will give you, and solve for x, and that gives you the exclusion. So when I look at my number line, the exclusion so far would be at 0. So I'm just going to draw this out so we can have a visual picture of what we're talking about. So it's everything this way towards infinity and everything this way towards negative infinity, except 0. Then we have to say, okay, we made a new function now. So we looked at the domain of what we inputted into here. And we have a new function, and that new function, so I'm going to write domain of g of x. The new function is f composite g of x. And so in the new function, which we found to be 4x over 1 plus 2x, this has a domain also where we have to find this domain. This has a denominator also. And so in this denominator, we can't put things because there's an x in there. So there's something that we have to exclude. So set the denominator equal to 0 and solve for x. So solving this one for x, I subtract 1 from both sides. I get this. And then I'm going to divide both sides by 2 because I need to isolate x, and this is 2 times x. So I get negative 1/2. And so again, this is another exclusion. Now notice I'm not worrying about the domain of f because that's not actually, we had to look at what we're inputting into f, and we had to, now we have a new function, the composite function. So those are the two things that we are concerned about. So now I have to look at, negative 1/2, that would be halfway between negative 1 and 0. And so now this is saying we have to exclude, so I'm just going to draw it up above, we have to exclude negative 1/2. So when you have the, when you're trying to find the domain of the composite function, well, you have to take into account that first you can't have 0 in it, and then you can't have negative 1/2. So then overall, we're talking about, and I'll draw the overall in a different color, we're talking about everything here, everything between negative 1/2 and 0, and everything this way. So the blue here is what I'm writing, and remember this goes to negative infinity and this goes to positive. So it's from negative infinity to negative 1/2, not including 1/2, union negative 1/2 to 0, union 0 to infinity. This will be the domain now. And that's written in interval notation. And then at the very end of this section, we have the writing a function as a composition. So it says express h of x as a composition of two functions. So this is saying, basically, if you were given the composite, if you're given this part, what are the two functions that were originated and got you to this? So let me show you how you should approach these problems. So the way you want to approach it is you have to think of it a little bit backwards. And you have to say whatever is underneath this radical. Right? There is a square root here. So take the square root and say that is going to be one of my functions, the square root function. And I need to come up with two functions so that when I do this, I get h of x, which is the square root of x squared plus 5. So inside the square root is x squared plus 5. So that's I'm going to, here, let me put it in yellow. That is what I'm inputting into the square root. So x squared plus 5. And then the square root, we're going to think of as the other function. So when you input x squared plus 5 into function f, you're going to end up with this. The two types of ones that you're going to see are going to be ones that have some type of radical in them. And the other ones might look something like this. Let's say we had j of x is equal to 1 over x plus 3. And when you have something in the denominator, you're going to think of this as the denominator is my inner function. And I can say, if I needed to come up with the two functions that make this, I would say my inner function is the denominator. And my other function would be 1 divided by that denominator. So when I input this into that, I end up with the overall function. So f of g of x is equal to j of x. So that's what we're looking at this, doing this. So let's do a couple practice ones. So let's say you had this, and you are asked to find f of g of x. So what we would do here is we would say, here's g of x. This is what g of x is equal to. I'm going to work from the inside out. And I'm going to say, I can put in, where's function f? Well, function f is 5 times the input plus 7. So in place of g of x, I'm going to put in x squared plus 4, wherever I have an input in f. And so this is now f of g of x. I'm going to simplify it by distributing the 5 to get 5x squared plus 20 plus 7. So I end up with 5x squared plus 27. So this is now f of g of x. Let's try a couple more. So here's our next problem, and our next problem says find f composite g of x and its domain. So we're going to take, and we know that f composite g of x is this. So in place of g of x, I'm going to plug in x minus 4. So I'm going to plug in x minus 4. So that means, what does that mean? I take function f, I look at it, here's function f. Function f, whatever you input into it, you're going to take the square root of the input. So the input is now x minus 4, so that's what's going to go under here. And so my answer would be this, the square root of x minus 4. You don't have to put the parentheses in there, it could look like this. Now the second part said find its domain. So the domain, we're going to first look at the domain of the interior function, so the g of x. Well, when I look at g of x, I can look at that and I can say g of x is all real numbers. So that would be everything in the number line. It does not have an x in the denominator. It does not have an x under the radical. But now I have to also look at the new function. So this one here. And so the new function doesn't have an x in the denominator, but it has an x under an even root radical. And so when it has an x under a even root radical, you're going to take the x, the radicand, x minus 4, and you're going to set it greater than or equal to 0. Add 4 to both sides to get x is greater than or equal to 4. And so then you're going to graph that on the number line. So let's say that this is 0, 1, 2, 3, 4. And so on the number line, it would be 4 and this way. So where are they both true? They are both true where they're both the green and the purple, and that would be from 4 to infinity. So this would be the domain of F composite G of X. Now the last thing that we're going to do is we're going to do an exit question. And so for the exit question, we'll have a question where we're going to complete it and you're going to upload it. So I'm going to give you the exit question here. And so the exit question says that you have f of x is equal to 5x minus 1. G of x is equal to 4x squared minus 3. And we have to find 4 things. We're going to find F composite G of x. We also want to do the composition the other way, G composite F of x. And then also we're going to take the composite, the new function, evaluated at -1, and take the composite, the new function, G composite F, and evaluate that at -1. And so you will submit your work and your 4 answers, box your 4 answers for these 4 questions. And then when we come to class next week, we will go through the answers to these 4 questions.